Hi there. In this tutorial, I am going to talk about the data analysis part of the augmented block design. This design will be used when the seed material required for the replication is not sufficient and also in the case when the number of treatments are high. So let me start with the basics of this experimental design. So this is the experimental layout of the augmented block design. Here we can see there are four blocks: block 1, block 2, block 3 and block 4. And in each and every block the chuck genotypes, which are C1, C2, C3, C4 and C5, are replicated and also randomized, and the error degrees of freedom of this experimental layout is 12, which is obtained by multiplying the degrees of freedom for chuck genotypes into the degrees of freedom of blocks, which is 4 into 3. So in order to do the data analysis of augmented block design, the important thing we need is the RStudio. In order to download this RStudio, we have to go to the Chrome and search for RStudio. So this is the official website of the RStudio. In order to download the RStudio, we have to go for products and select RStudio. And the RStudio required for us is RStudio desktop. So from here we can directly download the RStudio desktop. So I have already downloaded the RStudio desktop. So I will open directly from my PC RStudio. So this is the interface of RStudio. Here we can see there are four panes, and the first pane is the program pane. Here we will write the code required for the data analysis, and the second pane is the console, and the third pane is the environment, and the fourth pane is the packages pane. So or file pane. In order to do the data analysis, the next most important thing is the format with which we have to arrange the data. So let me jump into that. So this is the format with which we have to arrange the data. In this data frame, the two important columns are the block column and the treatment column. In the block column, we will mention the blocks, and in the treatment column, we will mention the genotypes. In the beginning of each block, we have to mention the data of chucks. Whatever may be the order of the chucks in different blocks, but while mentioning the chucks in Excel sheet, we have to maintain the sequence across each and every block. So, for example, here we can see the order of the chucks in first block is C1, C2, C3, C4 and C5, but in second block the C3 is the first chuck used and C4 is the last chuck used. But while mentioning in the Excel sheet, we have to maintain the uniformity. So chuck 1, chuck 2, chuck 3, chuck 4, chuck 5 in the first block, and this order is same in the block 2 also: chuck 1, chuck 2, chuck 3, chuck 4 and chuck 5. And this uniformity we have to maintain across all the blocks. In this tutorial, I am going to consider 5 quantitative traits for data analysis, which are plant height, pods per plant, seeds per pod, 100 seed weight, and yield per plant. After arranging the data in this fashion, we have to ensure that the spelling of chucks across each treatment is same, and we have to keep in mind that R is case sensitive. Suppose here we will mention capital C for chuck 1, and if we mention small c here in the block 2 for chuck 1, it is not going to work because R is case sensitive, and we have to make sure that we will avoid these kind of mistakes. And after arranging the data, we have to save this data frame, and we have to go to the RStudio for further data analysis. This is the program console. Here we are going to write the code which is required for the data analysis of augmented block design. and we all do it for the first time. We have to install the package which is required for the analysis of augmented block design, and the package is augmented RCBD, which this is the augmented RCBD package which can be downloaded and installed directly in our console. So the code is install dot packages. For the first time we have to mention that the package name in inverted commas. The package name is augmented capital RCBD, and we have to click Control and Enter to execute the code. So the package has been successfully installed. In order to load this package, we have to write the code, that is library augmented RCBD and execute this code. Now we can see that augmented RCBD has been successfully loaded. So after loading this package, we have to import the dataset. So in order to import the dataset, we have to click here import dataset and select from Excel. So those who are doing this for the first time, who have installed the RStudio first time, the RStudio asks for certain permission and you have to give yes for all the permission. Then this console opens. After opening of this console, we have to browse the location where the file has been located. So I have saved the file in desktop in the name of augmented RCBD, and so after selecting the file, by default it will be there in the first sheet. Yes, so if you have multiple number of sheets, so then you have to select the sheet in which the data is there. So after that we have to change the name into as simple as possible. So I will change the name into AGMNT. So after this we have to click import. So after importing we have to check the structure. So before checking the structure we have to change the options so that there will be maximum lines will be available to print in the console. So in order to change the print options, we have to give the code like this options in that max dot print. So we can select up to 10,000 or 1 lakh. So I will just select 10,000 lines. That means I need 10,000 lines, up to 10,000 lines to be printed in the console. After that we can check the structure of the data frame. Structure data frame AGMNT. So check the structure of the data frame. So here we can see that it is a table, which means table. So here we can see block, treatment, plant height, pots per plant, seeds per pot, 100 seed weight, and yield per plant. So the block and treatments are considered as characters in this table. So we need to change the block and treatments into factors. So in order to change the block and treatment as factor, we have to write the code like this. First select the data frame. In that we have to select block, and to convert that the code goes like this as dot factor. That we have to type once again AGMNT. So select the block, execute this line of code. So next we have to change the treatments. So select treatment, convert into factor. So execute this line of code. So in order to cross confirm whether the block and treatments have changed into factors, we have to check the structure of the data frame once again. To do that, just type str, which is the short form for structure, and write the data frame name. So here we can see that blocks and treatments are now converted into factors. Factor with 4 levels means it clearly indicates that there are 4 different blocks, that is 1, 2, 3, and 4, the 4 blocks which I have already discussed in the presentation. So here in the treatment we can see there are 101 levels, which means 101 different genotypes which are used in this experiment. 24 in each block, so 24 in 4 blocks means 24 into 4, 96. 96 entries are 96 varieties, and 5 chuck genotypes. 96 plus 5 is equals to 101 levels. So after cross confirming this, we have to write the code, and the code goes like this. The code which is needed for the augmented block design analysis goes like this. We would like to save the output in the factor known as b out. So b out, and the function to do the data analysis is augmented RCBD.bulk. Select the augmented RCBD.bulk function, and the first argument we have to mention is data, and here we have to justify the data frame name for data, that is AGMNT. After that we have to justify for the block. So block is equals to the name which we have given for block in our data frame, that is BLOCK. Here we have to cover it in inverted comma, and we have to mention capital B only because, as I told earlier, R is case sensitive. And after justifying block, after each and every argument we have to ensure we will put a comma after each and every argument. Later we have to justify for treatments. So treatment is equals to the name we are given for treatment, that is capital T, and this is also be enclosed in double inverted comma treatment. So after this argument we have to consider the triads. So since we are having more than one triads, we have to mention in C, open the parenthesis. After opening parenthesis, C, small bracket, 2 small brackets. So in that small brackets, mention the triad's name which is given in this data frame, that is pH, triple P, seeds per pod, SPP, 100 seed weight, yield per plant, as the shortcuts which we have given here has to be mentioned in this bracket. Inside these brackets also we have to enclose them in double inverted comma. The first triad is plant height. After each and every triad, make sure that you will give a comma. The next triad is pods per plant, triple P. After this triad, next triad is seeds per pod, SPP. After this triad, the fourth triad is 100 seed weight, 100 seed weight, and the last triad is yield per plant, YPP. After mentioning the triads, we have to give a different command which is chucks, small c h e case, chucks is equals to null. Don't worry much about this command, just give as it is. After giving this command, we have to describe the level of significance, that is alpha. For field experiment it will be 5%, 0.05. After describing the level of significance, and we have to specify that we need descriptive statistics, and the argument to get the descriptive statistics is describe. So we need descriptive statistics, so we will give true. After that, if frequency distribution of these quantity is also important for us, and we will need that too. So frequency distribution is equals to true. After that, we need also the genetic variability parameters, that is GCV and PCV. So in order to get that, we have to give the code GVA is equals to true. After this, we have to give color for each and every chuck used. So in this data analysis we are going to use 5 chucks, so we have to specify 5 different colors. So it is, so 5 different colors means more than one color which has to be mentioned within C and parenthesis. So chuck color, chuck dot col, so we have to mention it in C. That is, we have to select 5 different colors, those colors which has to be compatible in RStudio also. So if you don't know much about these colors, you just go and search for the colors which are compatible in R. So I will select 5 colors. The 5 colors are brown for the first check, dark cyan for the second check, forest green for the third check, purple for the fourth check. Yeah. Deep pink for the fifth check. After mentioning these colors inside parentheses, we have to give another default argument, that is console which is equals to true. The true should be given in capitals only. So after this, we can execute this line of code. Let me see whether this line of code doesn't have any errors. No, this line of code doesn't have any error. So within 2 or 3 seconds, all the data analysis of this number of entries has been completed successfully. Here we can see the ANOVA table. Here the ANOVA with treatment adjusted. Here it is the ANOVA with block adjusted, and we can get this report in Word format also. So in order to get the report in Word format, we have to give the code like this. The function is report augmented RCBD dot bulk, because we are using augmented RCBD bulk when the number of triads are more than one. After writing this function, we have to mention aug dot bulk, and we have to mention the factor where we have stored the output, that is b out. So just type b out and give a target. Just now I will give the temporary directory where this file will be stored. Target file path is equals to temporary directory. After this, we have to give the name of the word file. So I will write it as augmentedRCBD.docx. So after this, we just want to execute this line of code also. Yeah. So this line of code has some error in file path. See, docx not found. So sorry, here we have to mention the file name in inverted commas also. So augmentedRCBD.docx we have to mention in the inverted commas. So let me execute this now. Yeah, now it is working fine. Here we can see the red mark. So if you see, this means the report has been generating. So after the red mark has been stopped here, we have to know where the file has been located. So in order to find the temporary directory, just write the function temporary directory and execute this. So the temporary directory where the word file has been saved is, we have in C drive, we have to follow this path. Yeah, this path in order to find this temporary directory and in order to find the word file. So let's go to the Windows Explorer, and before looking into the temporary directory, we have to ensure that all the hidden files are shown. So just go to the view and click on hidden items. Go to view and click on hidden items. So after that, goes to this PC, Windows C. So and the location where it is saved is users and Harish Kumar, app data, local, yeah, in local temporary directory, and the name of the temporary directory is rtmpwwkt3x. Yeah, kt3x, find here kt3x. Yeah, here in this temporary directory, yeah, we can see the word file with the name what we mentioned in the console. So we just copy the entire folder, copy, and keep it on desktop. So let me go to the desktop and paste here. So we can rename this folder, rename. Let me show what are the things we will get. So these are all the graphs, the frequency distribution graphs and the GCV and PCV graphs. So we will be getting inside this word file. So let me show you how this word file looks, and this will ask this permission. This document contains fields that may refer to other fields. So we have to give yes. So simply give yes. After this, we will get a clean and nice report of our augmented block design. So here we can see the ANOVA with treatment adjusted, ANOVA of block adjusted. So the ANOVA which we use for this data analysis is ANOVA of block adjusted, and ANOVA of treatment adjusted is not so much popular, and we will also get the standard errors, and the standard errors in different combination, that is a test treatment and a control treatment, between two test treatments of different blocks and two test treatments of same block, like that. And it will be similar for critical difference also, CD at 5%, and here we can see the CV, the coefficient of variation, and it is high for the yield per plant, which is usually, and in the agriculture the CV will be around, the recommended CV or the considered amount of CV is around 6 to 24 as given in ICR guidelines. So these are the check statistics. So this is the descriptive statistics. Here we can see the minimum value and the maximum value. These are all the values with these are the values which we have to which is very much needed. So this is the frequency distribution table, not frequency distribution table, this is the frequency distribution chart. So continuous distribution, here we can see. So this is the table which has taken more place and not aligned, so we have to align manually. This is one of the problem in this package, but this problem is manageable. So just realigning it, we can see here we can see the genetic variability parameters, that is GCV, PCV and ECV, and with category also we will get, and for this the graphs also we will get. See, these are the graphs and these are the adjusted means. So these adjusted means will be used in order to calculate the genotypic correlations, and the original data what we have used for the data analysis will be used for calculating phenotypic correlation, and this will be same for phenotypic path analysis and genotypic path analysis also. For genotypic path analysis we'll use the same data that is the adjusted means data. So we can copy this adjusted means data into Excel sheet and we can further proceed into correlation and path analysis. So if you have any doubts regarding this data analysis tutorial, just please comment in the comment section and I will reply for your comments as soon as possible. Thank you.